Okay, good afternoon to all of you. Good afternoon to everyone. Good afternoon, everyone. Good afternoon to all of you. Okay, कल का PDF नहीं मिला, we'll send it. Don't worry. Okay. Good afternoon to everyone. Please let me know that the voice is clear, video is clear. Please let me know that the voice is clear, video is clear. Good afternoon. Good afternoon to all of you. Please let me know that the voice is clear, video is clear. Okay. And this is the Telegram channel. You people can join. It has also been given into the your description. Yeah, I know that the yesterday the PDFs has not been uploaded, but today it will be uploaded. Actually, there was one problem. Those who were present into the class, they might have known that the PDF was corrupted in between just because of long hour classes. Okay, so today we have to solve the MSQ questions. So these MSQ questions are game changing thing. So everyone please pay attention. Today we will solve the most of the questions, and as I told you, this is very important. Okay, these MSQ questions are very important. So please try to focus on this type of questions, and whatever you can get it, you can try to solve it. Okay, so if all of you are ready, then shall we start? If all of you are ready, then we can start and we can try to solve the questions as much as questions, because these all are MSQs and these all are very important, because as we know that so today we will have two classes. One is at 2 p.m. Right now, MSQ questions, and there is one more Maha Abhyas that is in Wallah EC EEE CS channel. Voice low? No, I don't think. Okay, try to solve this question. So here we will have the first questions which is related to that, and then it says that consider the statements below. Which of the following is not true? So here we are having three statements, and try to find out that which one of them is false, which one of them is true. Okay, try to solve this question. Yeah, it will be at around 7 p.m. So 7 p.m. you can get it. These all are MSQ questions. This series is related to MSQ questions, and there are few topics which has been left that we will cover at 7 p.m. So don't worry about it. But for now, try to solve this question. See, in this question, the most important part that they are asking is basically which one of the following is not going to be true. Which is not going to be true. Let's try to understand. That is the first thing. Okay. So basically in graph theory, always try to understand my point. In graph theory, the most important thing is we have to connect. Okay. Which one of them following is not true? So basically in a graph theory, you have to come up with a counter example. Let's try to see the first one. In a simple graph, 6 vertices, if a degree of each vertex is 2, then can we surely say that it is going to be connected? No, it's not necessary that it has to be connected. So for example, suppose if you will take this example, here you will take this graph, and here you will take this graph. So we can say that this is not going, it does not take a guarantee about that it is going to be connected, because they are saying that it should have a 6 vertices and degree of each vertex is 2. So a simple graph with 6 vertices, and if a degree of each vertex is 2, so you can come up with this type of disconnected graph. So right now this is a disconnected graph. So then the graph is connected? No. That is why the first statement will become false. So here you will get this statement, it is going to be false. Now try to take the second example. In a second example, in a simple graph G with 6 vertices, if a degree of each vertex is 2, then Euler circuit exists in G. Now even if you will see the second statement, for second statement also the counter example is this, because the Euler circuit will only related to the connected graph. Yesterday I told you, and yesterday I have also explained you the same concept. Okay, so it's not necessary that it has to be connected. So that is why the second statement, it is also going to be false. So with respect to MSQ, statement number 1 and statement number option A and B. So option A and B are going to be what? This is going to be your right answer. So statement number 3, in a simple graph 6 vertices, if a degree of each vertex is 3, then the graph is connected. Yes, this statement is going to be true, but in the question they are asking that which of the following is not true. So you can make a graph with respect to this also. Here we can get which is nothing but the connected graph. So the last option, statement number 3, it is going to be true, while the statement 1 and statement 2 are going to be false. That is why your answer will become A and B. Is it clear to everyone, or do you have any doubt related to this? Okay, do you have any doubt? If you have a doubt, we can clear it, or if you do not have a doubt, then fine, we'll start that. Do you have any doubt related to this? Please let me know. Clear everyone? Is it clear? Please let me know. Today, whatever we will discuss the question, all the questions will be related of MSQ. Okay, so please try to, your focus should be on the MSQ questions. So I hope that this has been clear to everyone. Okay, fine, good. Okay, now try to solve this question. Okay. Try to solve this question and let me know. Anyone? Okay. See how to solve this question. First of all, how many bijective functions satisfies the condition such that f of 1 should not be pointing to 1. So right now we are having this function, and what it says, uh, basically it is moving from A to A. So suppose if it is moving from A to A, So A will have a 7 different type of functions. 1, 2, 3, this is 4, this is 5, this is 6, this is 7. This is also 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So suppose if I will ask for total number of functions, okay, total number of bijective functions, total number of bijective functions, bijective functions. So basically what we have to calculate, we have to calculate total number of functions such that f of 1 should not be pointing to 1. So out of total, if I will calculate total functions, okay, total functions where f of 1 will only be pointing to 1. So total number of bijective functions that we will be getting is basically 7 factorial. Am I right? Now out of that we have to do the minus total number of functions where f of 1 will only pointing to 1. Suppose if you are saying that 1 is only pointing to 1, so how many bijective functions you will get it? So you will be getting 6 factorial. So what you want? See, try to understand what we want. We want total functions, okay, total functions, total bijective functions such that f of 1 should not be pointing to 1. It should be equals to total bijective function, okay, total bijective functions minus total bijective functions where f of 1 should be equals to 1. So total bijective functions will be how much? It will be 7 factorial. Now total bijective functions where f of 1 will only be pointing to 1, that will be, it will be 7 factorial minus 6 factorial. So definitely you can get your option B is also right, but if you try to solve this, you will get the actual value is 4320. So your correct answer will become, which is nothing but, you know, B and D. Is it clear to everyone? Please let me know. Is it clear? Did you get my point, everyone? Did you get the explanation? Yes, this lectures will be available over YT. Don't worry about it. Okay, so that is why you will get option B and D. So option B and D is right. Is it clear, everyone? How 6 factorial has been calculated? See, because if you are fixing this, you have to fix 1. With respect to this, total bijective functions where f of 1 is only pointing to 1. That means if 1 is only pointing to 1, so 1 does not have any other option. Now, if I will ask how many options that 2 can have, so 2 can have a 6 possibilities, 3 will have 5 possibilities. So if you are fixing 1 to 1, that means the remaining that can point it in how many ways? 6 factorial ways. Because if you are fixing 1 is only pointing to 1. So if 1 is only pointing to 1, so the remaining will have the 6 factorial possibilities. So because you have to calculate total bijective functions, okay, total bijective functions such that f of 1 will not point to 1. That means out of total, if you will do the minus total bijective functions where f of 1 will only point to 1. So when f of 1 will only point to 1, that means you are fixing 1 to 1 only. That means there is no option for this, there is no option for this. But the remaining will have that option. That means 2 can point it how many ways? 6 ways. 3 can point it how many ways? 5 ways. So the remaining will have the 6 factorial possibilities. Right? Because this option has been eliminated because f of 1 is only pointing to 1. So if f of 1 is only pointing to 1, so we cannot, right now the 1 cannot point to any other elements or no other elements can point to 1. So if you are fixing 1 to 1, so see, you can use the concept of inclusion where 1 to 1 is not pointing, that means total, out of total, if you will do the minus of, you know, f of 1 is only pointing to 1. So that is why 7 factorial minus 6 factorial. Got it? I hope that this has been clear to everyone. Clear? Okay, nice. Okay, So if you are ready, shall we move to the next one? Okay, try to solve this question. Which one of them is going to be a group? Yes, the lectures will be available over the YT, don't worry. What are the properties related to group? It should be closed, it should be associative, it should have the identity. Do you have that idea how to calculate this type of things? Do you know how to calculate this type of things? Whenever, suppose if the table has been given, based on table, can you find out which one of them is going to be group? Do you have that idea? यार वो फाइल तो करप्ट हो गई थी, बाकी का मैं भेज दे रहा हूँ. Okay, see, if you do not have that idea, I can teach you and I can let you know that. See, how to find out based on a group. See, there are four properties. Everyone, please listen carefully. With respect to group, it should satisfy the four property. Suppose if there is a set and then if there is a operation, the first property that it should be closed. Second property, it should be associative. Okay, associative. And then third property, it should have the identity. And then the fourth property, that it should have the inverse. Now, based on a table, how we can try to find it out? It's like a game. You people may have played the Sudoku game. The same type of game would be like that. The first thing, whenever you will have this table, how to find out these things? See, all the elements must not be repeated. That means in every row and in every column, all the elements must be uniquely present. That is the first criteria. So let's try to understand. Okay, let's try to understand. See here, as you can see that, see the first rule of a group in table, whenever you will try to understand, none of the row, none of the column should have the same repetitive values. See, as you can see that A is also present here, A is also present here. So in a single row, you are getting 2 times A. So this is not going to be group. Here, as you can see that same D and D both are present. So in a single row and in a single column, you should have the same number of, the element should not be repeating. Are you getting my point? the column and then the rows will have the unique values. That means this A, for example, suppose if this is A, so in this row only one A is present. In this row also only one A is present. If this is B, in this row only one B is present. In this row also only one B is present. Okay, that is the first property. So you should not have the repetition with respect to this. That is the one criteria that you people can try to get it. Okay. Okay. Get it my point? Today at around 7 p.m. we'll do that. Today at 7 p.m. we'll do that. Don't worry. Okay. Now, second point is because, so how to identify? See, for associative, you have to take few elements and then you have to try. Now, how to find out the identity? In order to find out the identity, the way these elements are appearing, so try to locate that which row is having the same elements appearing. So it can be either here, it can be either here, it can be either here. Suppose if this is the sequence of that element and if the same sequence is also present, then we can say that this element is going to be identity. Why? Because suppose if I'll write A, my answer with respect to identity, if I will write A, my answer will also be A. After the operation, whatever I will write, that will become my identity. That means if your input is also A and if your output is also A, so that means here if you will have element number 1, this is your input and output is also even. So that is why definitely this is going to be your identity element. Suppose if your input is E2 and your output is also E2, so if input is same, output is same, then the element will become what? Okay, the element will become, which we can say that the element will become the identity. Let's try to see that. See here as you can see that ABCD, this sequence ABCD, so definitely we can say that this will become our identity element. Here ABCD, here also ABCD, so we can say that this element is going to be identity. For associative, you have to take few elements, Aman. Okay, did you get my point? For associative, you have to check. Now identity, we got the identity. Now let's check for the inverse is existing or not. So for inverse, okay, for inverse, your answer should contain identity. That means each row contains identity. If each row contains identity, then the 100% the universe will be existing. So can we say that here in this row identity is present, in this row identity is present, in this row identity is present, in this row identity is present. So inverse of B is D, inverse of C is C, inverse of D is B. Here the identity is present, identity is present, identity is present. Okay, so here in the last one identity is not present, so this is not going to be group. Here identity is present, identity is present, identity is present, identity is present, right? So as we can see that in this everywhere the identity is present. So inverse of A is A, inverse of B is D, inverse of C is C, inverse of D is B. Here the inverse of A is A, inverse of B is B, inverse of C is C, inverse of D is D. Did you get my point? How to find out? Yes or no? So for identity, how to identify identity? When your input and output both are same, so the way this is appearing, it should appear in that way. The way this is appearing, it should appear in that way. So that will give you the criteria for identity. And for inverse, every row should contain the identity. Got it? Yes, Preetham. 7 o'clock we'll cover both. Don't worry about it. So can we say that B and C both will become your group? Can we say that B and C both will become your group? B is also your group. Understood? Can we take any element? No, you cannot take any element. देखो ये जिस सीक्वेंस में अपीयर होगा आंसर में भी उसी सीक्वेंस में जो चीज अपीयर होती है वो हमारा आइडेंटिटी होता है. गॉट इट. B is not, how B is not is going to be group. You take any example, B, C, D. Try to take example of B operation and then C operation and then D. B operation, C operation, D. What is your B operation C? This is B, this is C. Your operation, this one is D. D operation D. What is D operation D? You will get C. What is C operation D? C, this is D. You will get B. What is B operation B? You will get C. So, yes, it is also satisfying the associative law. How B is not closed? A, B, C, D, B, C, D, A, C, D, A, B, D, A, B, C. This is B, capital B, but this is B. So, yes, definitely it is a closed. You are getting all the elements from A, B, C, D only. Understood? You can take any example and you will try to find it out, you can get it. Is it clear? No, 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 this is small b. 1 minute, please. Is it clear to everyone or you need more? Is it clear or do you have any doubt or is it clear everyone? So yes, you will get this one is also right answer, this one is also right answer. So don't worry about it. So this is also your right answer and this is also your right answer. Okay, don't worry about it. So you'll get B and C both are right answer. Is it clear? Okay, I'll give you more questions on group theory because group theory is very important. But first of all, whatever the question you people are solving, you should tell me the answer. Okay, sir, I got it. Or if you have any doubt, how to check the identity, how to check the inverse, still I can make it very clear. But before, I mean, in order to, if you want me to explain, you should give me or you should tell me that, okay, sir, explain more into that. Then I will explain more. Associative, Aman, you have to check by taking elements, few elements. Okay, try to solve this question. Second one is true, but what about the first statement? If G is a finite group of even order, then there exists an element such that A square it is E. A square means yeah, you will get this is also true, this is also true, and this is also true. Finite of even order, then you can say that A will be same as A inverse because it will be in pair, even order mein hai to. Then definitely you can write this as A dot A inverse or A dot A, that means A dot this. What you can get? You can get E, which is nothing but A square. Or another way of writing this as A square A dot A dot A inverse. You will get E. So that is why first statement is also true and second statement is also true. Second statement is straightforward. AB square. So what you will write with respect to that? AB square. That means you can write this as AB and AB. Then you can write AA and then BB. Then you can write A square and then B square. So the second statement is also right. Understood? Very good. Is it clear? You can make these two theorem as a, you can consider these two things as a theorem. Statement 1 and statement 2 both are same. So your answer will become ABC. If it is MSQ, you have to consider all. Do you need more explanation on this? Let me know. Okay. See, the order is even. Please try to understand. The order is even. The order is even. Right? That means these statements will be even. These elements will be even. So order is even. This is also going to be even. right? This statement is also going to be even. Now everyone try to understand, suppose if we'll have that identity element, so the identity will have its own inverse, right? The total is even and the identity will become 1, right? The identity will become 1 and some elements will have, try to understand, so some elements will have their own pairs. For example, suppose if you will write x and then you will have that x inverse. So if I will go with inverse pairing, I will get 2 elements. ठीक है, मतलब एक आइडेंटिटी को निकाल दो, बाकी के सबका पेयर होगा, तो एक एलिमेंट ऐसा मिलेगा जो खुद का इनवर्स होगा. Did you get my point? For example, suppose if someone is having some more inverse, because the order is even, total order is even, okay, total order is even, so one element it is gone, right? One element is gone, and then here we will go with inverse pairing. We'll go with inverse pairing, which will give the even. So there is one more element that will be inverse of itself. समझ में आया? There is one more element, मतलब एक तो आइडेंटिटी हो गया, ये टोटल इवन है, एक आइडेंटिटी हो गया, और अगर मैं इनवर्स पेयरिंग में ले रहा हूं कि मतलब ए का इनवर्स बी हो गया, सी का इनवर्स डी हो गया, ठीक है, क्योंकि इवन ऑर्डर का है, तो अब ये 1 हो गया और ये इवन हो गया, तो 1 + 1 is odd but the total is even, so there is one more element which will be inverse of itself, and that element will become what? That element will become this, where a it is equals to this. So a square means a dot a, and then I will write a and then a, so you will get identity. So that is why a square, it will take the guarantee about a square will become the identity. समझ में आया ये? Maybe वो 2 element भी हो सकता है, but there is a guarantee that there will be one element which will satisfy this. Understood? Not understood? You need more explanation on statement 1? Please let me know. You can take this example. See, this example, this is of even order. A is a identity, A is a inverse of itself. ठीक है, तो एक चले गया. B और C का inverse pairing है, right? B और C का inverse pairing है. For example, see, this is of even order. This is of even order. Now try to see this. This is of even order. एक आइडेंटिटी हो गया और एक पेयर हो गया. पेयर में व्हाट यू कैन गेट? बी का डी और डी का बी. So B and D of inverse of each other. So C will be inverse of itself. C will be, there will be existing one element where it will be inverse of each other. So 1 is identity and 1. मतलब 1 + 1 is 2 and then pairing is even. So that's how A square will become E. Understood? आया समझ में? नहीं आया समझ में? सेकेंड वाले में क्या है? अगर ये होता है तो अबिलियन होगा. ये कब होगा? जब आप ये लिखोगे ना AB square, you can write AB and AB. That means the answer you are getting is A square B square. That means A B B. You can shift it. You can only shift it when it is going to be what? Abelian. So that is why the second statement is also true. आप कब shift कर सकते हो? When it is going to be abelian. When it is going to be abelian, then only you can shift it. So that is why the second statement is also true. Got it? Is it done? Clear? Please let me know. Okay, let's try to solve the next one. G8 is moving from R to R. Please solve, I'll be back in 1 minute. Statement 1 is asking for yes possibility. There exists. They are not taking a guarantee. They are saying that there exists. They are taking a guarantee for one element. Yes, A and B both will be right. Yeah, A square you will get 9. Did you get it or you want me to explain? Very good, Rohit. Yeah, you can put the values also. That is also one fine thing. You want me to explain or shall we move to the next question? But for pairing it will not be, na. We have to go for order pair. See, the order pair is very, very important. The order pair A comma B. The order pair. Okay. G of x is 1 minus x plus x square. F of x is ax plus b. Okay. F of x is ax plus b and g of x is 1 minus x plus x square. 1 minus x plus x square. Function क्या है? Function is GOF. 9x square minus 9x plus 3. 9x square minus 9x plus 3. That means GOF. That means here g and then f of x. What is g? G and then it will become ax plus b. That means g of x is this. So you will write, if you substitute here, see, try to understand my point. This is g of f of x. What is this? F of x is what? Ax plus b. That means if you substitute here, you will get 1 minus ax plus b and then plus a of x plus b and then the whole square. So you will write 1 minus ax minus b plus a square x square plus 2axb plus b square, and then this must be equals to 9x square minus 9x plus 3, right? So try to take all the values together. What you will get? You can write here, which is nothing but a square x square plus 2axb, right, and then minus ax plus b square minus b and positive 1. So you will write a square x square plus x, if you take common, 2ab minus a and then plus b square minus b plus 1. If you will compare 9x square minus 9x plus 3, that's how you will get a square, it is equals to 9. So the values of a you will get plus and minus 3. You just have to compare this. Got it? That is why the value of a you will get plus minus 9. Understood? बाकी का वैल्यू रख के you can substitute, no issue into that. Clear? Okay, let's move to the next one. There are two examples which has been given here. Okay, it is showing, no problem, but still I have given. Okay, it is showing here, no issue. There is no need to highlight this. Read this question properly, you will get your answer. These two are examples which has been given. Did you get this question or not? See what this question is trying to say, that you are at 2 comma 1. That means suppose if you are at 2 comma 1 and where you want to go, you are at 2 comma 1 and you want to go to 7 4. So there are only two options. You can get it. That means either you can take right or you can take up. So this is one example where you are taking right and then you are taking up, you are taking right, you are taking right, you are taking up, you are taking right, you are taking right. This is one example. If you will write the sequence of this, there will be right and then up and then right and then right and then up and then right and then right and then where there is one more up. So this is one example of this. Another example, here you are taking up and then right and then right and then right and then up, right and then right. So if you write the sequence of this, there is up and then 3 times right you are taking and then you will take up and then you will take right and right. So basically this question resembles to how many ways you can arrange these letters. That means there are 5 rights and 3 ups. So the whole question turns out to be how many ways we can arrange 5 rights and 3 ups. So how many ways you can do it? That you can do it in how many ways? 8 factorial and then divided by 5 factorial and then into 3 factorial. Am I right? Permutations with identical objects. The same type of question you people are solving. How many ways You can go for how many ways you can arrange databases, how many ways you can arrange Mississippi. वो वाला question है. तो ये पूरा question will turns out to be in this format. How many ways you can do 5 rights and 3 ups. So A and C will be right. समझ में आया question? Did you understand the questions? Please let me know. Is it clear to everyone? Please let me know. In the description box, the Telegram link is given. You can join it. The notes will be uploaded after this class. Try to find out in graph, try to find out the counter examples. You tell me, is it take the guarantee about the connectivity? Can we say that it two regular graph? Two regular graph, that means degrees of all vertices will be 2. And G has a perfect matching. Perfect matching, that means number of vertices are going to be even. Right? Two regular graph and then even number of vertices, that means it will have the perfect matching. G is a cycle of even length. Option A does not take the guarantee about the connectivity. Two regular graph, Manish, two regular graph does not take the guarantee about the connectivity. You take the example of this. So this statement is false. This statement is true. G is connected. No, this statement is false. This statement is true. So only B and D will become true. Cycle of even length means it is forcing for a connectivity. मतलब ये connected बोल रहा है, but जरूरी नहीं है. It might be true, may not be true. Done or doubt? Please let me know fast. Two regular graph does not take the guarantee about a cycle graph. Option first is saying that even length cycle. Option A is talking about the connected graph. G is not connected here. This is one example. Is it two regular? Yes. It is two regular? Yes. It has the perfect matching? Yes. These two conditions are satisfying by disconnected graph. Option D, what it is saying, every component of G is even cycle. That means this is also even cycle. This is also even cycle. मतलब अगर दो रेगुलर ग्राफ होगा और परफेक्ट मैचिंग होगा, परफेक्ट मैचिंग will take the guarantee about even number of vertices. Two regular graph means it will be the part of cycle. So it is also even cycle, it is also even cycle. You cannot take the example of C3. You cannot take the example of C5. So that is why the first statement is talking about the connected. इसलिए वो गलत है. अगर सिर्फ if I will introduce the two regular connected graph has a perfect matching, then the first statement will become right. Yes, two regular means degree of each vertex must be 2. Understood? Yeah, perfect matching you can exist into the disconnected, no issue. Clear? Why D? Because G, every component of G is even cycle. Because if it is a two regular and perfect matching, it should satisfy here also two regular and perfect matching, two regular and perfect matching. So that is why the D is true. In graph, देखो एक चीज, try to understand, very important point here. In graph, you have to come up with the counter example. You have to think and you have to come up with a counter example. Otherwise, you cannot solve any question of graph theory. So always remember, in graph theory, you have to come up with a counter example. In graph, you have to come up with a counter example. Done? If this question is done, we'll move to the next one. Yes, A and B will become right. Counter example of this is this. This is also false. This is also false. Yes, bipartite graph will be minimum of that. Done, everyone? I hope that it has been completed. Let's move to the next one. Yes, if in the option C, if they will give given minimum, then option C would also be true. Yeah, the correct answer is this. This is true, this is true, this is false. For example, suppose if R, if I will take only 1 and 2, this is transitive, yes, it is transitive. If I will take only 2 and 3, can we say it is a transitive? Yes, it is a transitive. But if you will take R union S, 1, 2 and 2, 3, this is not transitive. So you will get option A and B both. Done? Let's move to the next question. This is one of my favorite question. This is one of my favorite question. Please try to solve this. Yeah, with respect to reflexive union and intersection, H is a subgroup basically. Is it true? बहुत अच्छा क्वेश्चन है, कर लो इसको. What about reflexive? Yeah, ABC is right. Very good. बहुत ही अच्छा क्वेश्चन है ये. देखो इसमें दो चीज है. वन इज रिलेशन पार्ट, अनदर वन इज ग्रुप पार्ट. फर्स्ट लेट्स टॉक अबाउट रिफ्लेक्सिव. कॉन्सेप्ट क्या है? A is related to B such that A inverse B that belongs to subgroup. Now, what is the concept of reflexive? A must be related to A. Now, A must be related to A. That means A inverse and then A, that you will get identity, and identity belongs to H. So, this is going to be true. Hence, the option A is right. Understood? Matlab, you are having the relation part also and you are having the group part also. You have to take both in account. So this A is related to B when it will satisfy this equation. A is related to B when it will satisfy this equation. Now, what is symmetric? Symmetric says that A is related to B, it implies B is related to A. Group part, A inverse B, it implies B inverse A. It is also true because, for example, suppose if A inverse B, if it belongs to H, तो अगर ये एलिमेंट H से बिलोंग करेगा तो इसका इनवर्स भी बिलोंग करेगा. इसका इनवर्स क्या होता है? दिस विल बी द इनवर्स, एंड इसका आंसर क्या आ जाएगा? B इनवर्स एंड देन A. तो अगर ये इसका इनवर्स बिलोंग करेगा तो ये भी बिलोंग करेगा, विच बिलोंग्स टू H. सो दैट इज व्हाई इट इज सिमेट्रिक आल्सो. समझ में आया ये? दो चीज समझी क्या? नहीं समझ में आया? नहीं समझ में आया? How many of you have not understood this? This question is very beautiful. You can expect this question in examination. Transitive, that means this should belongs to H. That means AB and BC, it implies AC. AB के लिए A inverse B and BC के लिए B inverse C. So if you will combine this, A inverse B and then B inverse C, then A identity C, that means A inverse C will also belongs to H. Yes, that is why it is transitive also. क्वेश्चन क्या कहते, देखो क्वेश्चन ये कह रहा है कि जब ए बी से रिलेट करेगा तो कुछ कंडीशन दी होती है, राइट? रिलेट करने की कंडीशन क्या होती है? आपने क्वेश्चन पढ़ा होगा. रिलेट करने की कंडीशन होती है कि ए इज लेस देन और इक्वल टू बी. एक कंडीशन ऐसी होती है, या ए प्लस बी शुड बी इवन, वन टाइप ऑफ कंडीशन. but यहाँ पे the condition has been related to group theory. So you need the concept of relation and you need the concept of group theory also. That means A is related to B. See, simply what it is saying, for example, suppose if I will talk about relation, मैं सिर्फ अगर relation के बारे में बात करूँ, तो you will have this relation, there is a relation such that A is related to B, condition is A plus B, it is going to be even. ये we usually learn this thing into relation. Now suppose if I will talk about reflexive, so you says that A is related to A, that means when it will satisfy this condition, A plus A, it is going to be even. Yes, definitely it is going to be even. But this is not our question. What is our question? Our question says that there is a relation R such that A comma B is related when A inverse B and then that belongs to H. Now let's talk about the first one, which is reflexive property. Reflexive property says that A is related to A. A is related to A, that means A inverse A, that belongs to H. But what is the value of this? This is value of identity. Identity belongs to H. Yes, this is true. So that definitely we can say that it is going to reflexive. Understood? This is order pair, this is condition. This is normally we used to learn into the relation. But here the relation and group theory both has been combined. So A is related to B when it will satisfy this equation. Clear? Did you get my point? Now here all the explanation. So for reflexive, yes, this is true. That means identity belongs to H because H is a subgroup. So if H is a subgroup, it contains the identity. So definitely it is going to be true. Symmetric, A is related to B, it implies B is related to A. What is the condition of A is related to B? Condition of A is related to B, that means A inverse B, it implies B inverse A. Suppose if this element belongs to H, so definitely its inverse also belongs to H. Why? Because H is a subgroup. So if this element belongs to H, the inverse of this will also belongs to H. So what is the inverse of this? So inverse of this is this. So definitely this will also belongs to H. So that is why this will also belongs to H. So that is why it is symmetric. And same concept with respect to transitive also. This is very beautiful question. One of my favorite question. Done everyone? Clear? Okay, let's move then. It was good question. Okay, there are 3 more questions which is related to group, same type of question. Please try to solve by yourself. Okay, and I am giving this over the group so you can also understand. So that's it for the today. There is one more Mahabhyas. If you want to do, you can come at 7 p.m. in the evening. Okay, 2 or 3 group questions are like that. I hope that you people have solved and you enjoy the questions. And there is one more session, Mahabhyas, 7 p.m. If you want to solve the question, please come. You will have more questions there. And we'll also do the remaining revisions. Okay, so thank you so much. I think we have solved 14-15 questions and then the remaining is there. You can solve it. So see you at 7 p.m. Thank you so much.